Hey everybody, so we are in our last week of classes and I want to show you how you can figure out some fundamental properties of matter. Okay, so we're going to go all the way back to the beginning of the semester here. We're talking about solids, liquids, and gases, and essentially we're going to be able to answer the question of why some substances under certain conditions, like certain temperatures and pressures, will be gases, and some will be liquids, and some will be solids. All right, and so this does apply to your everyday experience, believe it or not. So I have here just some ethanol hand sanitizer, okay? So I didn't want to use very much. I put it in a little shot glass, but just some plain old regular hand sanitizer. And I put some dye in it so we could see it a little better on the camera, right? And so the dye makes a homogeneous mixture. I just had to stir it. It's fine. Now, the next thing I'm going to do is just pour some water into it, okay? So if you know anything about hand sanitizer, it's an organic molecule called ethanol, or sometimes they use isopropyl alcohol, but they're both alcohols. We're not going to go into the organic chemistry part of it, but we can understand whether these things will mix. So I have water, and I have basically gel ethanol. So when I pour them together, we see this kind of cloudiness. I'll put a little more in. You see that? A little cloudiness that happens. You can see you can kind of still see the gel in there. Almost kind of looks like Jell-O. So I'm going to mix it. You can't tell if things are going to be soluble unless you mix them. And I don't know. What do you think? Did it dissolve? If I keep mixing forever and ever and ever, they're going to dissolve? I don't know. There's like little chunks of gel in there. I'm not sure if you can see that on the camera. Probably if I mixed longer, or if I could add more water, maybe they would dissolve. But it doesn't look super miscible, which is different from if I just take some water. If I just take some plain old regular water, and I put in some dye. Let's be crazy and go blue. How about that? We used pink last time. Turned out more red than pink, though. Oh, I'm getting blue dye all over my fingers. Awesome. Well, how about this? I'm just going to dip my finger in. And immediately you can see that it solubilizes the dye that's on my fingers. Right? And so we didn't even get to see the mixing lines. It happens so quickly and so smoothly. You don't even see it in separate phases. So apparently food dye is soluble in water. It's also soluble in ethanol. It took a lot more effort to get that to happen. I had to stir it longer. So food dye seems like it can mix with at least a couple of different things. So now I'm wondering whether food dye might be able to mix with some oil. Okay. So oils are hydrocarbons, meaning just made out of carbon and hydrogen. Sometimes there's a little bit of like oxygen on the end of it, but pretty much it's largely carbon and hydrogen. Okay, so with that piece of knowledge, here is some veggie oil. I'm not sure which veggie oil, but you know, it's the clearest oil that I have at home. I use a lot of like olive oil, so I had to look for something a little less colorful. And so I want you to watch when I drop this in. You see that? Putting quite a bit in, actually. It reminds me of these drinks from the 90s. I don't know. This is before some of you were born, but there were these drinks. I think they were called Orbits or something like that, but they had these little kind of gel gooby things in there. I don't even know what they're called, but they had these gel things suspended in the drink, and it kind of looks like that to me a little bit. Kind of like tapioca in bubble tea, almost. So still, I left it there for a minute. I'm going to try stirring it. All I have is my Sharpie that's that. So it made them smaller little circles, but it didn't mix. So then the next question is, well, what would happen if I take some of the water and I put it in here? Ooh, did you see that? I don't know if you saw that. Put a little more water in. Okay, so now we see the blue pretty quickly collecting down at the bottom where the water layer is, and in this particular instance the vegetable oil is on the top. And in between we have this really gnarly looking bubble area where you have mixtures of probably some air, but also the dye and the water and the oil together. And of course we know that oil and water don't mix together, right? One's polar, the other one's non-polar. But I'll try it just to prove it to you. Okay. Still not mixed. I give it a good stir, still didn't mix. Okay. So the question is why? Why don't these two liquids mix? When you think about putting two liquids together, most of the time we would envision they'll mix together pretty well. This did not. We have two layers here. Fun thing you can do with that, by the way, is if you have some Alka-Seltzer, this will generate bubbles, right? If you have some Alka-Seltzer, you can take these. It's a great activity to do with little kids. It blows their mind every time. But you take your oil, food coloring, and water, and you just throw one of those in there. And once it hits, it's on the wrong side of the beaker. Once it hits there, it starts to bubble. And you've just made your very own lava lamp. I'm going to put another one in. It's fun. So what's happening is the bubbles, which are carbon dioxide, are rising to the top, and as bubbles do, right? Because they are less dense than liquids by a lot. The water is needed for that reaction to happen. You got to react the Alka-Seltzer with the water. And so these big bubbles are going from the water layer up through the oil layer, but they don't mix. They're not miscible. Okay? So miscible would be if things mixed. Miscible, mixable. Sounds the same. In this case, we don't see that. What we see is the oil and the water layers are not miscible. So we will say that's immiscible. Not mixable. Okay, I could watch this all day. It's fascinating. But the question is, it smells kind of good, actually. I know that Alka-Seltzer does not taste good. Oh, it's lemon flavored, which probably means it has citric acid in it. Anyway, so now I have this blue dye on my fingers, right? Because the container was open for some reason. If I want to get this blue dye off, I know that using a solvent that is polar is going to work better than a solvent that is non-polar, because we just tested that, right? So the oil is non-polar, and so if I used an oil-based solvent to wash this off, it's not going to matter because it's not miscible. They don't mix. Because they don't have complementary intermolecular forces. So that's what Chapter 11 is about. All right, so here's some thought questions to begin your study of Chapter 11. This is going to connect it back to the beginning of the semester, so give a few minutes, jot down a few ideas, and we will discuss them briefly at the beginning of class.